Thank you to Trade Coffee for sponsoring this video. Visit drinktrade.com/realscience to enjoy 30% off your first month of coffee. A battle cry rings out across the Antarctic islands. These are the Titans of the Southern Ocean, 4 tons of raw sexual aggression, battling for the beach. Southern elephant seal males fight for dominance and to protect their hard-won harems, which can consist of 150 females or more. Fights between dominant males and challengers can be long, bloody, and extremely violent, with the loser often suffering serious injury or even death. But the rewards can be great. The highest-ranking males may father up to 500 pups in their lifetime. But the journey to becoming a so-called beach master is fraught with difficulty, because these behemoths don't start their lives being so formidable. Life is hard for the youngest elephant seals, and sometimes they take an unusual path. In October 2020, researchers came across a baby southern elephant seal in Salem Bay in Tasmania, an extraordinarily rare occurrence ever since humans decimated their population there from hunting. Today, the closest breeding colony to Tasmania is some 1,500 kilometers away, close to Antarctica. The pup they discovered was just one of 5 pups known to have been successfully weaned on Tasmania in the last 40 years. The pup eventually grew up and swam off into the ocean, and researchers thought that might be the last they see of him. But southern elephant seals have a strong attachment to the area where they were born, and once a year, they come ashore. And so in July 2021, the rare young seal reappeared, and this time he was ready for chaos. Meet Neil the seal, a lovable doofus known for getting into fights with orange traffic cones, barring people's access to their cars, and trying to break into garages.
Neil, don't even think about it.
He's gone from a wide-eyed pup to a large juvenile, and the growing has only just begun. Scientists from the Marine Conservation Program decided to relocate him away from this highly populated area, but that didn't stop Neil from returning to more human habitats in 2022, and 2023, and 2024.
You can't keep doing this. Neil, you need to be quiet. You've had me up since 3 o'clock. You broke the garage again.
And this could become a problem for the humans in contact with Neil.
Ah, you big tubber lad.
Because you really do not want to cross the path of a fully grown male southern elephant seal. Despite looking like clumsy blobs of jello, southern elephant seals are anything but. They are absolutely enormous, crushing machines. And they're super adapted diving machines, diving deeper than almost any other mammal on Earth. And being a male often means being a valiant warrior, engaging in those brutal fights for dominance. Some of their anatomical features are truly bizarre, from their enormous proboscis from which they got their name, to the total shedding of their fur and skin every year. And their social system and breeding lives are among the most extreme and most brutal in the animal kingdom. For now, Neil seems determined to hang out with the humans. But if Neil manages to make it to adulthood, he might just end up being a beach master, siring hundreds of pups. But he's got a long road ahead of him, with plenty of obstacles. When you think of the largest members of the carnivora order, your mind might go to a wolf, or maybe a tiger, or maybe a grizzly or polar bear. These are formidable animals indeed, but none are even close to the size of the largest of the carnivora order, the southern elephant seal. The largest female ever found was 1,000 kilograms or 2,200 pounds, and 3.7 meters or 12 feet long. But this pales in comparison to the largest male ever found, which was 6.85 meters or 22.5 feet long, and was estimated to weigh 5,000 kilograms or 11,000 pounds. The southern elephant seal is the larger of the 2 species of elephant seals. A bull southern elephant seal is about 40% heavier than a northern elephant seal. These giants are the largest marine mammals outside of the cetaceans, and are twice as heavy as a walrus and 7 times as heavy as a polar bear. And the reason for their enormous size is for males to fend off mating rivals. And while necessary for mating, the size of these giants can pose a great threat to other seals in their colony, notably the babies. Early in their lives, southern elephant seals face the greatest threats: that they'll starve once they're weaned off milk, that they'll get eaten by a bigger predator the first time they go for a swim, or that they'll be squashed by a giant male. The on-land mortality for newly weaned pups is between 2 and 10%. But things get much dicier when they first dive into the water. Only 30 to 40% of seals survive their first dive, with the majority getting picked off by orcas or sharks. Considering all these early obstacles, it's a bit of a miracle that Neil made it back onto land in Tasmania. That said, southern elephant seals are made for water. Though they may look like awkward blobs on land, their bodies are incredibly well adapted for the sea. A layer of blubber keeps them warm in the waters around Antarctica. Their bodies are streamlined for cutting through the water, and their fins help propel them without expending too much energy. They are open ocean predators who spend most of their time at sea. When they're not mating or molting, they have to be constantly hunting in order to pack on the pounds. They can eat anywhere from 4.8 to 16 kilograms of fish and squid per day. But to get so large, these seals hunt for the biggest fish and squid they can find. And these types of large fish are not readily available in shallow water. They have to go deeper than almost any other animal to find them. Southern elephant seals are the deepest diving seals and some of the deepest diving mammals, period. They've been recorded going as deep as 2,388 meters down and staying submerged for 2 hours. For comparison, this is about the same as a sperm whale and comes second only to the Cuvier's beaked whale, the mammal that's thought to be the world's deepest diver. Once at depth, elephant seals mostly locate their prey using vision, sometimes using the bioluminescence of their prey to hone in on them. Elephant seals don't have a developed system of echolocation like whales and dolphins do, but their facial whiskers are sensitive to vibrations and are assumed to play a role in the search for food. But how does this blob of a beast dive so deep at all? Sinking is indeed a challenge for something so blubbery. They have to propel themselves downward with their fins until negative buoyancy takes over. But another pressing question is, how do they dive so unbelievably frequently? For how deep they're diving, scientists hypothesized that they'd need a long recovery period at the surface between dives, for 2 reasons. 1, to stay within their aerobic limit, and 2, to ward off decompression sickness. But one elephant seal being monitored by scientists stayed at the surface for only 2.5 minutes after a 2-hour dive. It dove right back down again with seemingly no problem. In the same study, another seal who was monitored for more than 40 days spent no longer than 6 minutes at the surface at any given time. From a fatigue standpoint, this is impressive enough. I know after I've been freediving down while snorkeling, I need a solid amount of time to recover and catch my breath again. But from a decompression standpoint, this is even more impressive. For a long time, it was believed that marine mammals can't get decompression sickness. Humans often suffer this affliction after scuba diving, where we breathe compressed air underwater for a long period. Under increased pressure underwater, the inert gas nitrogen that we breathe from the tank has a chance to dissolve into our tissues. When we ascend from the dive, the dissolved and harmless nitrogen in the bloodstream turns into dangerous bubbles, and at that point, we get the bends. Marine mammals, on the other hand, are diving from a single breath hold, not from a tank of air. So the volume of inert gas within their bodies under pressure is inherently less than a scuba diver's. And this does mean marine mammals don't get the bends very easily. But decompression stress can and does happen. Scientists investigated recently stranded beaked whales and found substantial nitrogen bubbles in their tissues that decomposition alone couldn't explain. In addition, scientists have found damage to sperm whale bone tissue, which they attribute to repetitive decompression stress. Humans avoid this stress by not diving too deep, ascending slowly, and by staying at the surface between dives for a precisely calculated and sometimes lengthy amount of time. So how do elephant seals, the second deepest diving mammal with no dive computer and lightning-fast surface intervals, avoid it? First, by doing exactly the opposite of what humans do when diving. Free diving, that is. Imagine you're about to dive down to retrieve something that you know is pretty deep. What do you do before diving down? Probably take the biggest breath you can, stocking up on as much oxygen as possible. But this is not at all the strategy that elephant seals employ. Before their mind-bending deep dives, they breathe out everything from their lungs. By doing so, they are getting rid of as much nitrogen as possible, minimizing their risk of decompression injury. But aren't they also getting rid of all their oxygen? Not exactly, because the precious oxygen that they'll need for their dive is not stored in their lungs, but in their red blood cells and muscles. And they have a lot of blood, twice as much as humans relative to their size, meaning that even if humans were exactly the same size as the seals, they'd still have twice as much as us. And their muscles can store and bind 3 times more oxygen than human muscle, thanks to high quantities of myoglobin. Their bodies also undergo a dive response, with blood being shunted away from the extremities and moved toward the heart and brain. Their heart rate can even drop to 2 beats per minute. And as an elephant seal dives deeper and deeper, their lungs collapse. This forces air into the trachea and prevents gas exchange between the lungs and blood, further helping to prevent decompression illness. And while helpful for diving deep, this could be a problem when coming back up. If the lung tissue sticks in on itself, the lungs might not be able to reinflate. But elephant seals have another weird trick up their sleeves, or rather trick up their lungs. If you're ever in a position to see an elephant seal sneeze, you'll see a gross, bright white fluid come out of their nose. This is pulmonary surfactant. All mammals have pulmonary surfactant to help them breathe. It reduces surface tension at the alveoli, helping oxygen in gas form enter the liquid environment of the bloodstream. But in elephant seals, it plays a secondary function. It acts as an anti-adhesive, making their rapid ascents and rapid re-expansion of the lungs possible. It's like Pam spray for lungs. But even with all of these factors, southern elephant seal dives are so deep and so long that scientists thought that there was no way it was possible for it all to be done with aerobic respiration. Meaning that scientists thought surely there just can't be enough oxygen stored in their bodies to dive the way they do. The aerobic dive limit is defined as the longest dive that an air-breathing animal can make while relying on oxygen stored in the lungs, blood, and muscles to maintain aerobic metabolism. With such long dives and with such short surface intervals, it looks like elephant seals constantly exceed their aerobic dive limit, meaning they should be entering anaerobic respiration regularly, but they don't. This might sound like we're talking about the seals breathing, but aerobic and anaerobic respiration are actually chemical reactions taking place within the cells, where they are making energy for the body. In aerobic respiration, oxygen and glucose make energy available to the cell in the form of ATP, producing carbon dioxide and water as the byproducts. In anaerobic respiration, there is no oxygen, so the cell generates ATP through a lactate dehydrogenase reaction. Anaerobic respiration is way less efficient, but can help animals in a pinch. So the question with these deep diving elephant seals remains: how do they manage to stay in aerobic respiration for so long? Nobody really knows. Scientists think that in order for the seals to dive for 50 to 60 to 120 minutes and maintain aerobic respiration, they'd have to reduce their metabolic rate to 50%, meaning their cells would have to be doing half as much respiration as normal. And we just don't know how they do this. Maybe they shut down certain organs like the kidney and the liver, but they can't turn off their stomach or digestive system because during these months at sea, southern elephant seals are trying to gain a ton of weight. And they aren't simply getting fat for the sake of it. They're preparing to come ashore for mating season, during which they go months without eating, and every pound could help towards a victory in a battle for the beach. Male and female elephant seals have quite different life experiences, starting from the time they're juveniles all the way through adulthood. It takes female seals 3 to 4 years to reach sexual maturity, at which point they can begin breeding. It takes 5 to 6 years for males to reach sexual maturity, but their social maturity comes much later. They're not likely to start breeding until they're 10, almost halfway through their life. And even then, most males are unlikely to be successful at reproducing. Southern elephant seals are the most sexually dimorphic of any mammal species, meaning they have the greatest size difference between males and females. Males continue growing throughout their lives, and they tend to forage in different habitats than females, where there's a higher risk of predation by orcas and sleeper sharks, but also more food. And the males need to take that risk, because they must get as big as possible. Only the very largest and most aggressive males become beach masters, the enormous alpha males who can have a harem of hundreds of female seals. The mating season starts with the males coming ashore first, usually returning to the place they were born. Depending on which mating colony they belong to, they haul out around August or September and begin fighting for territory. Loud roars begin to permeate the beaches, enabled by the male's proboscis. That's the weird-looking growth on their face, unique just to the males. And it's something that's been commented on by scientists for more than 100 years, going all the way back to Charles Darwin, who described it as an appendage that becomes greatly elongated during the breeding season and can then be erected. In this state, it's sometimes a foot in length. As Darwin noted, the proboscis gets larger during the mating season for several specific reasons. First, it helps provide a visual signifier. I'm big, don't mess with me. But it also contributes to the seal's vocalizations. Before the males ever think about engaging in physical confrontations, they roar at each other. The proboscis increases the length of the vocal tract, which changes the sound and may make the seal sound even larger than its actual size. And bigger, older males are much more likely to be successful beach masters. So when a young, smaller male hears the call of an older male, he's more likely to back down without a fight. But if two competitors are more or less the same size, they start fighting physically. They have huge lower canine teeth and will start smashing into each other's heads and biting. Remember this video of Neil making himself tall? It's actually him practicing that fighting behavior that might one day help him become a beach master. Most of the fights end before either seal is injured severely enough to cause death, but rarely the fight will be violent enough to kill one of the males. And if they don't die, the losers can either wander over to another part of the beach and look for someone else to challenge, or they can give up. That seems to be what happens for the vast majority of males, because only about 1% are responsible for 85 to 90% of all successful inseminations. Then, once the males have secured their territory, they wait for the females to haul out. But the mating doesn't start right away. First, the females give birth to the pups they've been gestating since the last mating season. Then they feed milk to their new pup for about 24 days. It's only after all of this has happened that the males start mating with the females they've defended. They can be aggressive and overeager with the females, and sometimes this results in pups getting crushed. For the more than 2 months that males are on shore, and just over a month that females are there, neither eat anything. Only the new pups are gaining weight. All adults are losing weight at a remarkable pace. For the males, they end up losing about 40% of their body mass, or 12 kilograms every day. The females lose about 35% of their body mass. This might sound surprising because the females are the ones feeding the new pup. But remember that males spend about a month longer on shore not eating, while they wait for the females to arrive. As soon as the breeding season is over, the adults get back into the water, ready for food, while the young are on their own to figure out hunting and staying alive. But this foraging period is a short one, because there's one more haul out for the adults and juveniles alike, and this time, it's for the catastrophic molt. Maybe you've seen some of the videos of Neil in people's yards where he's looking a bit scraggly. I know the first time I saw it, I wondered what was going on and if Neil was okay. But the peeling going on around his body is a totally normal part of the southern elephant seal life cycle. It's called the catastrophic molt, and occurs a few months after the breeding season when the seals have had a chance to catch some food and put on a bit more weight. Molting is extremely demanding. The seals lose both their fur and the upper layer of their skin. On the simplest level, molting is when animals shed their skin, fur, or feathers. This can happen due to changing seasons, like when cats shed their winter fur in the spring. Or it can be because the animals are growing larger, as with snakes and lizards who shed all the skin from their body at once. Even humans have a less dramatic version of this. We shed skin cells all the time, as old pieces of the epidermis are replaced by new ones. Going back to the elephant seals, their epidermis has 3 layers. It's this top layer of cornified epidermis that the seals lose, along with their fur. And shedding it is such an energetically costly process that the seal's metabolism ramps up 2 or 3 times its normal rate. Pretty inconvenient, since they're stuck on land and away from food when it happens. But elephant seals aren't shedding their skin to emerge in a bigger body like snakes do, and so shedding all that skin at once seems extreme. So why do they do it, and why do they have to undergo this process once a year, every year? It's because of their watery lifestyle. During the rest of the year, while they're hunting in the water, blood is moved away from their skin to provide oxygen to their organs and keep the rest of their body warm. In order to have the necessary blood flow to their skin to trigger a molt, they have to be on land, away from the cold water. So instead of flaking off bits of skin all the time the way humans do, the seals shed everything in one go on land when they won't freeze to death doing so. It's also thought that the catastrophic molt in southern elephant seals could help them get rid of contaminants that build up in their bodies, like mercury from the fish they eat, which is a pretty cool trick if that's how it works. But the molt seems to be an all-around uncomfortable process. The seals have a harder time with thermoregulation, sometimes getting too hot and slipping into the water to cool off, but sometimes getting too cold and needing to huddle together in large congregations to share body heat. They also might scratch themselves or throw sand on their bodies to help with the temperature problem. And for a long time, researchers thought the seals were going hungry during this whole process. After all, females tend to lose around 150 kilograms during this 1-month molt period. But a brand new study found that some of these seals actually are eating. Researchers equipped female elephant seals with time depth recorders to monitor their dives, and stomach temperature pills that show when the temperature changes if seals are eating or drinking. And they found that about half of the females in their study performed several dives, and most of them ingested prey during the molt. The seals were pretty choosy about which days they went diving. When there was less wind and higher air temperature, they were more likely to go for a swim, which makes sense considering they probably got chilly pretty quickly. And hunting for a little snack while molting also seemed to pay off. The more the females dove and ate, the less mass they lost during the molt. So maybe sometimes the molt isn't the worst thing ever, but it sure looks itchy, especially if you're not going for regular swims. Maybe that's why Neil has tried to break into so many people's garages. He's uncomfortable and a little hangry. Whether Neil will become one of the beach masters who gets to mate with dozens or hundreds of females remains to be seen. When it comes to courtship, we can't all be so lucky as to look like this. And beating up all the other competitors for partners is generally frowned upon in our society. So without these magnificent gargantuan battle bodies, us humans unfortunately have to do something else to win over our partners. We do silly things like dating or giving gifts to show potential or current partners we would like to be their mate. And while there's lots of things that could be gifts, there is one that is completely universal, and that is coffee. When my husband and I first started dating, he would bring me a coffee every day, which honestly was a lot of hassle for him, but it was much appreciated. But now there's a much easier way to give the gift of coffee, and that is this video's sponsor, Trade Coffee. Trade delivers the best at-home coffee experience right to your door. And this is no ordinary coffee. Trade scours the country looking for the nation's top roasters, then grinds, brews, and tastes thousands of options. Once tested, they curate the best of the best coffee for their site. To date, only about 500 have made the cut. And by answering a few questions, Trade will match you with exactly the type of coffee you like, using machine learning, while also letting you try new things that you might not realize you really love. For example, I don't like dark roasts, but I love light roasts, and I always want my coffee to be whole bean so it stays fresher longer. I filled this in on the Trade site, and it's been able to map my preferences to hundreds of different coffee flavor profiles. It's been so fun getting new recommendations and trying new coffees that I never would have been able to get before. I recently moved from Austin, Texas to a rural area in New England, so as you might guess, my coffee shop options have plummeted. Yes, there are about 25 Dunkin' Donuts in a 3-mile radius, but it's just not the same. But thanks to Trade, I still get to drink some of the best coffee in the country, all while enjoying the quiet beauty of the woods. You don't have to live in a city anymore to get a fantastic coffee experience. So whether you want to give the gift of Trade as a gift to a partner or as a gift to yourself, Trade offers unlimited flexibility that will meet your exact needs, guaranteed. Each coffee is roasted and packaged to order and delivered on your desired schedule. It makes me look forward to starting every morning, and I look forward to receiving their iconic red bag every time. Thank you to Trade for sponsoring this video. Visit drinktrade.com/realscience to enjoy 30% off your first month of coffee.